Assalamualaikum and hello. We from Timothy's group. We going present to you about ionic bonding. So let's go.
What is definition of ionic bonding? Ionic bonding is a type of chemical bonding that involves the electrostatic attraction between oppositely charged ions, positively charged and negatively charged. The general information of ionic bonding: matter all around us is composed of tiny atoms of different elements with inherently very physical properties, which then give rise to different phenomena. For instance, bonding. The individual atoms that comprise of matter are chemically bonded together, and one such type is ionic bonding. Plainly speaking, ionic bonding occurs as a result of Coulomb force between metal and non-metal ions. As is known in physics as well as in everyday life, oppositely charged things are inherently attracted to one another. The same applies for the tiny atom all around us. This is periodic table of elements. From this table, we can know metal and non-metal element because ionic bonding only occur between metal and non-metal element. So here we have sodium with an atomic number 11 has 11 proton and 11 electron. Having the same amount, its net charge is 0 and is therefore neutral. Now, the same is true for the chlorine Cl. For its 17 proton and electron, it also has a neutral charge. By themselves, these two are inherently unstable because of the octet rule. According to the octet rule, atoms have a certain tendency to prefer 8 electrons on its outermost shell. Second, atom tends to gain, lose, or share electrons. This is the image of how an ionic bond formed between sodium ion and chlorine ion. So, let's see the explanation how an NaCl is formed. We observed just now from the image that sodium only has a single electron on its outermost shell, whereas chlorine has 7. Because of this, the extra 1 electron in sodium will tend to transfer onto the chlorine atom, so that sodium loses its outermost shell and thereby have the already completed 8 electron on its next one has its new outermost shell. Next, chlorine then receives the extra electron to complete its shell. This process happens because of the inherent difference in their electronegativity, a measure of tendency of atom to attract electron. A higher value makes an atom more likely to accept an electron, while the individual atoms are now stable. The process has changed the respective charge of the two. Then, as sodium loses an electron, it now becomes positively charged, and chlorine receives an extra electron, it becomes negatively charged. The resulting ions are thereby attracted to one another, forming the ionic bond. From this image, as stated before, this kind of bonding occurs between metal and non-metal atoms. As per their definition, metal are elements that form positive ion by losing electron during chemical reaction, and non-metal are elements that tends to gain electron to form negative ion, anion, during chemical reaction. These are because of their inherently different electronegativity value. Non-metal have higher value over metal, as they are the ones to accept the electron, giving them the negative charge. Here are some other ionic compound, metal plus non-metal.
Examples of ionic bonding: sodium bromide, potassium bromide, sodium fluoride, potassium iodide, potassium chloride, calcium chloride, potassium oxide, and magnesium oxide. Different metals and nonmetals have different valence electron counts, and therefore have different charges when ionized. These give rise to the varying strengths of the bonds. Given that the force between two charged particles is proportional to the product of their charges, it follows that ions with larger charges produce stronger bonds. Moreover, the potential energy between the two is also proportional to the product of their charges. The potential energy of the lattice is given by these equations, where the first expression refers to the net potential energy between Na and Cl ions, and the second refers to the energy caused by the overlap between the shells of the atoms. Anions and cations alternate. Large numbers of positive and negative ions held in 3D. Each is held strongly by electrostatic force of attraction called ionic bonding. In NaCl, each sodium ion is surrounded by 6 chloride ions. Considering this three-dimensional structure, the forces and energies within are more complex as you have to deal with both attractive and repulsive ions.
Characteristics and properties of ionic bonds. Ionic bonds and therefore ionic compounds have some key characteristics. First, strong. Since it utilizes electrostatic force, it is characteristically strong. From having high forces, it also follows that these compounds require a higher amount of energy to break and therefore have higher melting and boiling points. Second, exist in solid. They also exist in solid state at room temperature because the strong bonds between their oppositely charged ions lock them into place in the crystal. Soluble in water. It is soluble in water due to its polar nature and high dielectric constant. However, it is not soluble in non-polar solvents such as benzene and carbon tetrachloride. Ionic compounds dissolve in water if the energy given off when the ions interact with water molecules compensates for the energy needed to break the ionic bonds in the solid and the energy required to separate the water molecules so that the ions can be inserted into solution. Last but not least, conduct electric. One of the most important about ionic bonding is it can conduct electricity as there are positive and negative charges between the atoms, but it needs to be in the aqueous form. It is because in molten state or dissolved state, ionic compounds conduct electricity because they contain charged particles called cation and anions. These ions are free to move to conduct electricity. In solid state, the movement of ion is restricted because the ions are held together in fixed positions by strong electrostatic force and cannot move freely. Thus, ionic compounds conduct electricity in molten state or solution, but in solid state, they do not conduct electricity. Next, move to application of ionic bonds. Lithium fluoride. Lithium fluoride is commonly used as plugs in ceramics and glassware. It also has been used as powerful source for small long-life batteries. Potassium iodide. Potassium iodide can block absorption of radioactive molecules. It also has been used particularly on patients receiving radioactive treatments. Potassium iodide has melting point of 686.1 degrees Celsius and also boiling point of 1330 degrees Celsius. Sodium chloride. The sodium chloride, or commonly called the table salt, has melting point of 800 degrees Celsius and boiling point of 1465 degrees Celsius. As conclusion, the concept of ionic bonds has been widely used and practiced nowadays. The characteristics and properties of the ionic bonds, such as strong, exist in solid, soluble in water, and conduct electricity, have made the ionic bond to become an important bonding concept to produce a lot of useful things, such as sodium chloride or table salt, lithium fluoride, and potassium iodide. That's all. Thank you.